Space Test Program is the primary provider for spaceflight for the United States Department of Defense, space science, and technology communities. The Space Test Program flew its first mission on the Space Shuttle in 1982 as a payload on the STS-4. In the post-Space Shuttle era, STP has focused its efforts on the development, evaluation, and advancement of new technologies needed for the future of spaceflight. Also by utilizing foreign and commercial launch vehicles such as the Japanese HTV, Russian Progress, the European ATV, and even the Russian Mir space station, STP has in total launched 588 experiments on 251 missions. For its most recent mission, the STP H-5, or H-5, was prepared for launch at Kennedy Space Center's Space Station Processing Facility in Florida.
We're at Kennedy Space Center's Space Station Processing Facility. It's our last stop before we turn the payload over to the launch vehicle and basically kick it off Earth so we can start getting science on orbit. Okay, so this is a complement of experiments. There are 13 total. Really, they don't have much to do with each other. We find as many experiments as possible that are compatible with each other on a single pallet of this size, and it's about a meter by a meter cube. And we make sure we have power, data, and mass handling resources available to each of these experiments in a single package.
As the great unknown in the ultimate high ground, space has been, and still is, an enticing environment for exploration. Because of the endless possibilities, the United States Air Force and NASA has shared a very unique relationship in their efforts to further exploration and provide access to space. The Space Test Program's partnership with NASA, not only Johnson Space Center, but Marshall Space Flight Center, will provide space access to their experiments that otherwise do not have the means to access space. These experiments will demonstrate new technology in the realm of space environment, weather analysis, new spacecraft subsystem demonstrations, as well as space situational awareness, rendezvous, and proximity operations.
Space station is huge, and it's got very good systems designed for flying the space station, but some of the accuracy that we need out in the external world where we're on a flexible structure that could be affected by sun and thermal and even what the astronauts are doing on the inside can affect which way we're pointing. So we have this star tracker here to make sure we know where our entire pallet is pointed, and the experimenters will be able to use that data on the ground to post-process and figure out exactly what they were looking at when their science was taken. One of the more visible aspects of STP H-5 is a two-axis gimbaled suite of instruments provided by the Goddard Space Flight Center. And they're going to use these instruments to actually track visiting vehicles as they approach the International Space Station. It's an experiment where they're going to try to just open loop track where they'll predict where the vehicles are and see how their instruments react to those vehicles as they get close to space station. And then they'll graduate the science experiment into more and more complicated closed loop sessions where they will actually use the instruments to steer the box. And this application for the Goddard Space Flight Center is going to be used on their future missions where they will do robotic servicing of other satellites and potentially even used on the asteroid rendezvous mission where those vehicles weren't designed to have someone fly to it and dock with it. So it's an extremely innovative way to do automated rendezvous techniques.
After a successful launch from Launch Complex 39 at the Kennedy Space Center, the STP H-5 payload pallet was removed from the trunk section of the Dragon C-12 spacecraft and was successfully deployed to the exterior of the International Space Station, also known as the ISS. The STP H-5 mission will provide opportunities for DoD and civilian space agencies to perform on-orbit research and technology demonstrations from the ISS.